Okay, so here's what we have for absolute value. My absolute value has a parent function that looks like this. Notice it goes for the origin and it's two straight lines or diagonal lines going to the left and the right. So for this one, my vertex, I'm going to color code it a little bit. My vertex is this point right here. It's the lowest or highest point of my graph, and it happens to be at 0, 0. For my axis of symmetry, symmetry is wherever you can cut your graph in half and have the same thing on both left and right side. So for this graph, I can definitely cut it in half down the middle. I'll run color down the middle here. Notice that line goes through the x-axis at x equals 0. For my domain, I go from left to right. So we're going to go from left to right. On the left side, I have an arrow, and that arrow keeps going forever and ever. On the right side, I have an arrow, and that arrow keeps going forever and ever. So my domain is negative infinity to positive infinity or real numbers. My range, for that one, I have to go from bottom to top. On the bottom, it looks like this right here is my lowest point, which is where y is 0. And then on the top, my graph goes on forever and ever, so it's positive infinity. So I start at 0 and I go on forever and ever to positive infinity, or y is greater than or equal to 0 if we do an equality notation. X-intercepts is where my graph crosses the x-axis. It also happens to be this very special point, which is also my vertex for this problem. It won't always be your vertex, but it just happens to be. So my x-intercept is right here at 0, 0, or where x equals 0. My y-intercept, we're going to do the same thing. Follow the graph on the y-axis and see where it crosses your graph. It happens to be the same point again. That won't always happen, but because it's a parent function, it shares all those attributes where my y-intercept is also the x-intercept and it's also the vertex.